Hello, this is Dr. Christy Patton-Lukes, and this video lesson is going to be on how we can use MATLAB to solve differential equations that have analytic solutions. So this is doing this, like the correct mathematical answer. And so we're just going to start by looking at a simple little example here, right? This dy dx equals y has the solution y equals a constant times e to the x. And you can get C by knowing an initial condition or a boundary condition. And so this one we know what the answer is. That's useful because then we're able to ask MATLAB to solve it, and when it gets the correct answer, then you feel like you've done a good job. But then that gives us the training to solve more complex problems later. So what I want to do is come to MATLAB, and the formula or the function that we're going to use in MATLAB is dsolve. So it's a differential equation solver, and in parentheses you're going to put the equation. Now the equation is going to be a capital D to represent the d dx, or if it had been dt or whatever your variables are. It sort of doesn't matter. The independent variable is, immaterial at that point. Okay, so the derivative of y is equal to y is my equation to solve, and when I do this, it gives me the answer, c1 times e to the t. Okay, and if I want to do this using a boundary condition, then I'm going to start with the same, but then I'm going to put in the boundary conditions, and again in single quotes, y of 0 equals 2, for instance. Okay, or I could do okay, so any number of things, and notice that it's putting in exp of -1 there, but that's still just a constant, and so I can do any number of these various forms. And you could of course do more complex ones. Here's another example. dy equals 2 times y over, and since the independent variable that it uses is t, we'll do t instead of x, and an initial condition. Okay, y at -1 is 1, and the answer is t squared, y equals t squared. Okay, now if you really don't want to have t as your variable, you can put in something else. You could choose an x. So for instance, dsolve dy equals y, subject to y of 0 equals 1, and then in parenthesis x. And so now then it uses exponential of x instead of exponential of t. But the default is going to be t. You can do this for multiple equations if you have a system of differential equations. Just list them in order as you go through and do this. For instance, let's see. And we end up with a system of equations. Let's see, will it let me, because I didn't define a variable? Yeah, okay. So if I want to look at what the x part is, this is the function for that. Okay, and I could similarly do the y portion. Okay, Oh, because answer changed. This is where you get into trouble for having not remembered to, up at the top, if I had said G equals okay, and now I could look at G dot Y, G dot X, and it will give me the various components of that system. But you see how easy it is for problems where you have an analytical solution. So we're going to stop that here, and in the next video lesson we're going to look at cases where I can't do an analytical solution and need a numerical approximation.